Welcome to Lesson 6.1, Understand the Linux File System. We will cover what a file system is and how it's organized and how an administrator interacts with the file system. So conceptually, a file system is a namespace organized into a hierarchy. And so what we mean by that is there's some set of names, like file names and directory names, and they're organized in some hierarchical structure separated by slashes, generally. A file system is also an application programming interface, or an API. It is a tool that processes, applications, programmers can use to interface with the underlying actual storage system. So it's sort of an abstraction layer, so you can have a file sitting on some disk device. It's also, it includes a security model. So we need to make sure that the users that are authorized to access a given file have permissions to do so, and the users that do not have those permissions. So a file system has structures in place to permit or prevent access to a given user. The file system is the software that takes all of these kind of logical notions that we just discussed and ties them into the underlying hardware, the disk underneath the virtual file system. The kernel itself supports many different types of file systems, many different implementations of them, and there's a lot of nuances and complexities to different file systems that have different features. The Linux file system is usually ext3 or ext4. That's just the type of file system that is the default on many Linux systems. There are many other types of file systems out there that support various features. The file system is used for a variety of purposes. It is primarily for the administrator's use. It's used to represent and organize storage resources. So if I have a CD-ROM drive and a solid-state disk drive and a rotating standard kind of platter disk drive on the system, those all appear under a single namespace, the root, the slash namespace. And the file system is just this nice abstraction that lets us interface with all of those different devices kind of through one common element. So it's also a way for us to interface with the kernel directly. Through the /proc file system, we can configure the kernel. So there's some nice abstractions there for us. It is also used for inter-process communications. If I have a process running and it needs to communicate with another process, it can do so through a file system abstraction. This is commonly the case with web applications, for instance. You might have a web server interfacing with the actual web application through a Unix file system socket. In the most general sense, it's a place for us to organize and store files for the system. So we've seen that throughout as we've been interacting with the Linux system. Touching the file system is the thing that we do very commonly. Let's check out a couple of gotchas with the Linux file system. First, let's understand what an absolute versus a relative path is. So I can check out the file Gettysburg Address, the file we've been interacting with throughout this series so far. This is known as the relative path, meaning it's relative to the directory I'm currently in. I'm not giving it any qualifier, I'm just saying list the file. The fully qualified path would be /home, /vagrant, /Gettysburg Address. So this is known as the fully qualified path. We can also refer to it in shorthand as ./Gettysburg Address, meaning the current directory is known as dot, and then slash to separate the directory from the file, and then the file name. And yet another example would be tilde, my home directory, /Gettysburg Address. These are all various ways to refer to exactly the same thing. There's some other nuances. What if I wanted to have a file called Gettysburg space address? I can use the touch command, Gettysburg space address. But now if I do a list, I have Gettysburg here and I have address here. It created two different files. So I need to put quotes around it. I need to say touch Gettysburg address with a quote. So you can have spaces in file names, but they just need to be quoted, because otherwise the shell thinks it's a separate part of the command, another argument to the command. As we learned before, hidden files always start with a dot, and you can view them with the -a command. Notice that if I just type ls, like I did in this example, we see all the files in the directory, but we don't see any files with a dot in front of them, like the bash files that we learned about before. These are prefixed with a dot, and so they're hidden unless you type minus A. We can look at the current directory with dot. Or if I do a long listing with hidden files, I see dot here, which is referring to the current directory that I'm in. And then dot dot indicates the parent directory, or in this case, I'm in Vagrant, home Vagrant, so dot is home Vagrant, and dot dot is /home. PWD, which I've been typing all along, is print working directory and shows where I'm currently located.